In this video, we will talk about behavior-based aggregation of land categories. We are Carlos Dobler and Jan Xu Hong, graduate students of Clark's University Geography program. This video will address three major points. First, we will explain behavior-based aggregation. Next, we will describe the benefits of using it. Lastly, we will present free software developed to perform behavior-based aggregation, and will give instructions on how to use the software. You might be wondering, what is category aggregation? Category aggregation is a procedure that combines two or more categories to create a single broader category. For example, the map in the left has three categories, A, B, and C. If we aggregate categories B and C, we then only have two categories, A and the union of B and C. Aggregation can be very useful in cases where we have many categories, because interpretation is easier with fewer categories. This is an area in northeastern Massachusetts. These maps have 15 land categories for two time points, 2001 and 2011. Maps come from the National Land Cover Database. 15 categories can be challenging to understand, so we would like to aggregate the categories. But first, let's have a look at some important transitions. This is a transition table for the maps presented before. A transition table is a useful tool to analyze changes between two time points. The rows show the categories at time 1, and the columns show the same sequence of categories at time 2. The entries on the diagonal are the number of pixels that didn't change between time points. Entries off the diagonal are the number of pixels that transitioned from one category to a different category between time points. This transition has 225 entries. However, we can see that a great number of pixels transition from open space to developed with low and medium intensity. Also, a great number of pixels transition from developed with low intensity to developed with medium intensity, and from medium intensity to high intensity. Another way of looking at the transitions is with this graph, where the horizontal axis is the percent of the study extent. We have segmented bar for each of the 15 categories. The green striped segment shows the size of the gain. The blue solid segment shows the size of the persistent, and the red dotted segment the size of the loss. The bars show that the developed categories are very dynamic. Deciduous forest transitions to open space. Open space transitions to low intensity. Low intensity transitions to medium intensity. And medium intensity transitions to high intensity. A useful aggregation will help us reduce the number of categories and simultaneously maintain these large transitions. The National Land Cover Database has an aggregation from 15 categories to 9 categories, based on the conceptual similarity of the categories. You can see again maps for 2001 and 2011 for the same area, aggregated into 9 categories. Indeed, the aggregation has fewer categories, but the aggregation has eliminated many transitions. We have now only one urban category that gains from forest. The aggregation from the 4 developed categories to one urban category has eliminated information concerning transitions among the 4 developed categories. The aggregation from 15 to 9 categories has eliminated change. The upper bar shows the percent of the study area that changed according to the 15 categories, while the lower bar shows the percent of the study area that changed according to the 9 categories. As you can see, the aggregation has eliminated half of the change. This is what happened when the rules for aggregation ignore the category's behavior in terms of gains, losses, and transitions. Behavior-based aggregation is a method of aggregation that aims to reduce the number of categories while maintaining a substantial portion of the original amount of change. As its name says, this method of aggregation is based on each category's behavior. So, what is the behavior of a category? The behavior of a category concerns the category's loss gain, and transition, with other categories as shown in the transition table. Suppose we have again three categories, A, B, and C. The map on the left shows the categories distribution at time 1. The map on the right shows time 2. You can see each category gains and loses various amount of pixels for this time interval. For example, category A loses 28 and gains 4. Therefore, category A is a net loser because it loses more than it gains. Category B and C are net gainers because they both gain more than they lose. Behavior-based aggregation can aggregate a net gainer with another net gainer, or can aggregate a net loser with another net loser. However, behavior-based aggregation never aggregates a net gainer with a net loser. These are maps from the same area aggregated into 5 categories. This aggregation was performed using behavior-based aggregation. As you can see, the behavior-based aggregation maintains the various developed categories that account for much of the change. Behavior-based aggregation maintains the important transitions while decreasing the number of categories to 5. The behavior-based aggregation produces a set of 5 categories that show nearly as much change as the original 15 categories. You can perform behavior-based aggregation with your own data. Please visit the website to download an Excel file for free. The Excel file has a macro that performs behavior-based aggregation. When you open the Excel file, you must first read the documentation sheet to learn how to operate this program. And then, on the input sheet, click the green button to start running the program. Input in the gray cells the original number of categories in your transition table and labels for time 1 and time 2. Then, click the red button to enter the matrix. The macro goes to the sheet called matrix 15 because we entered 15 categories on the input sheet. We must enter the names of the categories and the number of pixels for all of the entries in the transition table, shown by the gray cells. Like this. Then click the red button to run the algorithm. We can get the result of every step of the behavior-based aggregation shown in each Excel sheet. 2 categories are aggregated in each step. The 2 categories appear at the bottom of each matrix. These 2 categories have the same net direction. For example, in matrix 6, the type of the 2 aggregated categories are net gaining. The output sheet shows the 2 categories that are aggregated at each step and their corresponding net direction. In addition, we can also see the total change decreases gradually from the original 4.91% to the final 2.86%. The output sheet also has a chart of percentage of total change at each aggregation step. Our results show that total change begins to shrink sharply when there are 5 categories. This result helped us to decide to aggregate our data to 5 categories. You can choose the number of categories according to your own data. This video has shown that, first, aggregation can reduce the number of categories, but can also reduce the change in a transition table. Next, behavior-based aggregation aims to maintain the change. And lastly, you can perform behavior-based aggregation with your data using free software. The National Science Foundation and Clark University supported this work so that you can get manuscripts and software at Professor Pontius' website for free. You should read these 2 papers and perform behavior-based aggregation with your own data.